Assalamu alaikum. Today we discuss the topic that is the numerical problems. First numerical that we discussed that is what is the average translation kinetic energy of molecule in a gas at temperature of 27 degrees centigrade. We know that the formula of temperature that is equal to T is equal to 2 by 3K average kinetic energy. From this we can calculate the average kinetic energy that is equal to 3K T over 2. Here the temperature is given 27 degrees centigrade, so we convert it into the Kelvin. 27 plus 273 is equal to 300 Kelvin. So put it this value in this numerical. 3 value of K is equal to 1.38 10 to power minus 23. So put it here 1.38 10 to power minus 23. Temperature is 300 over 2. If we calculate it, simplify it, we get answer 621 into 10 to power minus 23. That is the kinetic energy. Now we calculate the average speed of the oxygen molecule in the air as standard temperature and pressure. एवरेज स्पीड फाइंड करनी है. एवरेज स्पीड का फार्मूला है इज इक्वल टू √3 RT/m. सो हेयर mass of the oxygen molecule is 32 gram. If we convert into kg, 0.032 kg. So put it here value. So we can calculate the average speed. Constant R value is 8.314. Temperature is standard temperature. So if temperature is 0 degrees centigrade, so if we convert it into Kelvin, 0 degree centigrade plus 273 is equal to 273 Kelvin. That is the temperature. Put it here 273. Our mass is given 0.032. So we calculate it. If we multiply it, this is 6809.166 over 0.032. If we divide it, we get 212,786.43. And if we under root it, we get answer is 461 meter per second. That is the answer. Now we find the average speed of the nitrogen molecule. That mass of the nitrogen molecule is 28 gram. If we convert into kg, 0.028 kg under standard temperature and pressure. So the temperature is equal to 8 plus 273 is equal to 273 Kelvin. So average speed is equal to 3RT/m. 0.314. Temperature is 273 and mass is 0.028. So in under root we get 243,184.5. If we simplify it, we get the answer 493 meter per second. That is the average speed of nitrogen. Now we solve the numerical related to the equivalence of heat and work. What is numerical? A heat engine operates with 65 kilocalories of heat supplied and exhausts 40 kilocalories of heat. How much work did the engine do? So first heat that is given is 65 kilocalorie. Second heat is given 40 kilocalorie. So we know that the equivalence of heat and work constant is equal to 4.184 joule per calories. And we know the formula that is W is equal to JQ. Here is the Q can be found by separating Q1 minus Q2. Putting the values 4.18 is joule per calories. If we represent it to kilojoule, it can write 4184 kilojoule per calories. So here it is 4184 kilojoule per calories. Q1 is 65 minus Q2 is 40. So answer is equal to 104,600 joule. That is the work done that engine do. Assalamu alaikum student. Today we discuss the numerical problem that is related to the first law of thermodynamics. First problem is in a certain process 400 joule of heat energy is supplied to the system. So here heat energy Q is supplied to the system at the same time of 150 joule of work is done by the system. Work is done by the system, so work is positive and heat is also positive because it's supplied to the system. So here we write the find the increase in internal energy of the system. This is the internal energy denoted by U. So here we know that the first law of thermodynamics that is equal to Q is equal to del U plus W. Here we find the del U, Q minus W. Q is given 400 joule minus work done is given 150 joule. So change in internal energy is equal to 250 joule. This is the internal energy that is increased when we supply the heat energy. Hence they say that the anhydrous gas observe a 5 10 to the power 3 joule of energy that is represented by Q while doing 2 10 to the power 3 joule of work on the environment during a constant process. So here the work done is W. Compute the change in internal energy of the gas. So in first part we find the change in internal energy. We know that Q is equal to del U plus W. Internal energy find, so work done come here and become minus. So here we can find del U. Q is given 5 10 to the power 3 minus W is given 2 10 to the power 3. So del U is equal to 3 10 to the power 3 joule. That is the change in internal energy. Now we find the B part. In B part, if internal energy now drop by 4.50 10 to the power 3 joule, internal energy drop. So here the internal energy will take the minus and 7.50 10 to the power 3 joule is expelled from the system. Then this heat energy is expelled from the system, so it take minus. Find the change in volume. We find the change in volume by constant pressure that is given. So here we write the formula of constant pressure, that is Q is equal to del U plus P del V. So P del V is equal to Q minus del U. Put the formula of values of Q. Q is minus 7.50 10 to the power 3 minus because it is expelled from the system. And internal energy also is decreased 4.50 10 to the power 3 joule. So P del V is equal to P del is V is equal to minus 3 10 to the power 3. So here we find the change in volume. So change in volume is equal to minus 3 10 to the power 3 over P. We know that the P value is given 1.01 10 to the power 5. So here del V is equal to minus 2.97 10 to the power minus 2 meter cube. Why don't diesel engine have spark plug? In diesel engine don't depend on the spark plug to ignite the fuel. They depend on the principle of compression ignition. When the air is compressed by high temperature and pressure, it heat up. When the fuel is injected, it combusts spontaneously. Now we discuss the another numerical problem, that is the reversible engine work between the two temperature whose difference is 100 degree centigrade. So temperature difference is given the 100 degree centigrade, that we can write 100 Kelvin. It is observed 746 joule heat from the source and reject Q2 heat to the sink. So Q2 is equal to 546 joule. Calculate the temperature of the source. So source temperature is represented by T1. So here we find the T1. We know that the formula of efficiency is Q1 minus Q2 over Q1 is equal to T1 minus T2 over T1. So here Q1 is 746 minus Q2 is 546. Our Q1 is 746. Difference of temperature is given 100. Temperature T1 is fine. So here we can write 200 over 746 is equal to 100 over T1. So we can find T1 that is equal to 373 Kelvin. That is equal to 100 degree centigrade. If the T1 is 100 degree centigrade, so we can find T1 minus T2 that is equal to 100 degree centigrade. If T2 is equal to that 100 minus T1, that 100 minus T1 is equal to 100. So we find T2 is equal to 0 degree centigrade. So we find T1 is equal to 100 degree centigrade and T2 is equal to 0 degree centigrade. Now we discuss the numerical problem, that is what is the change in internal energy of 200 gram of nitrogen. It is heated from 10 degrees centigrade to 30 degrees centigrade. So here we find change in internal energy. Nitrogen mass is given is 200 gram and it is heated from temperature T1 to T2 at constant volume. So here is given the mass of the nitrogen is 200 gram. We want to calculate that is the change in internal energy. Change in internal energy, that formula and CV delta T. Here we want to find the N. So we can find the N by formula of ratio of the mass of nitrogen over the molar mass of nitrogen. Mass of nitrogen is 200 gram and molar mass is the 28 gram per mole. So here we can calculate the number of moles, 7.143 mole. CV value is given in the question. Change in temperature we can find T2 minus T1. Here the T2 is given is 30 degrees centigrade and T1 is given 10 degrees centigrade. So delta T is equal to 20 degrees centigrade, that is equal to 20 K. So here we can find delta U and CV delta T. Value of number of mole is 7.143. CV is 20.815. Delta T is given 20. So change in internal energy is equal to 2973.6. That is the change in internal energy. Now we discuss the next numerical question. That is the refrigerator has a coefficient of performance is 8. So here we write coefficient of performance of refrigerator is 8. If the temperature in the freezer is minus 23 degrees centigrade, temperature of the freezer, then the T2 is given the minus 23 degrees centigrade. It change into Kelvin. So T2 is equal to 250 Kelvin. So what is the temperature at which the reject heat? So we find if reject heat is T1. So here the coefficient of performance formula of the refrigerator is T2 over T1 minus T2. So T2 is equal to 250. T1 find करना है. T2 is 250. Coefficient of performance that is equal to 8. So cross multiplication 8 T1 minus 250 is equal to 250. Multiply it. It become 2000 is equal to 250. So 250 plus 200,000 is equal to, here the T1 value is equal to 281 Kelvin. That is the answer. Today we discuss the numerical question of related to the thermodynamic. First numerical question is a Carnot heat engine has a maximum efficiency of 55%. If the temperature of heat source is T1 is 600 Kelvin, then find T2. So we know the formula of efficiency, that is equal to 1 minus T2 over T1. So here T2 is find करना है. So here we write 1 minus eta is equal to T2 over T1. Value of eta is, if efficiency 55%, then we can write 0.55. So here is minus 0.55 T2 over T1. So here T2 over T1 is equal to 0.45. So T2 is equal to 0.45 multiplied by T1. So here T1 is 600 Kelvin, so 0.45 multiplied by 600. So T2 is equal to 270 Kelvin. That is the answer. Now find what is the change in entropy of 30 gram of water. So here the mass is given and temperature is given, T 0 degree centigrade as change into height and related heat of fusion of ice is, that is given the hf. So here we know that delta q is equal to mhf. So mass is 30 gram, change into the kg. So here we write 0.03 kg. So here 0.03 kg. Relative heat of fusion is 336,000 joule per kg. So del q is equal to 180 joule. That is the heat. What is the change in entropy? We find the change in entropy. So we know that the change in entropy is equal to del q over del T. So delta q is equal to 180. Our temperature, that is given T degree centigrade, T 0 degree centigrade. It change into the Kelvin at 273 Kelvin. So temperature is equal to 273 Kelvin. So it is equal to 273. So here the delta S is equal to 36.92 joule per Kelvin. That is the entropy of the water. This is the answer.